Math and physics. How are math and physics related? Yes, so is business.
Like the laws.
What laws? You're right, it is the laws of nature. Gravity is a law of nature. Buoyancy is a law of nature. So everything of that. So basically, the way they're related is physics is mathematics in motion. Think of any moving body, any physical object, whether it's physical or theoretical, mathematics proves it or disproves it. Airplanes. What makes an airplane fly? What's that? No.
Aerodynamics.
Of what? Aerodynamics is the science that makes it fly, but what? It's more called fluid dynamics. It's how the air goes over. But what makes it fly? What do you have to have in an airplane to make it fly? You don't need an engine. Gliders fly. Of what? What's that? A glider doesn't have gasoline. You may have gas inside the cockpit if you ate too much Mexican food.
Wings.
Wings, exactly right. At first, everybody thought that it's just a tear shape. A wing was a tear shape. But what they figured out, even the shape of a wing, of a bird's wing, looks like this. A gentleman named Bernoulli came up with this concept. What makes wings fly? What makes birds fly when they flap their wings? It's not everybody think, okay, when you push down on the wings, you're pushing the air up. Yeah, that's true. But what keeps them up once they're in the air? This. As the object is going forward, the air is moving at the same speed, or the wing is going through the air at the same speed. So all this air is right there. When it gets to this air, what happens to this air that hits it pretty much head on? Where does it go?
Down.
Well, it's the bottom of it goes down, the top of it goes up. But here's the interesting that Bernoulli found. The air, if it's right here, it will always stay at the same place. In other words, if it hits the wing, the air is not going to stop where it is. The air keeps on moving. So what happens is this air and this air have got to change speed. It's got to increase. Since this top side is more curved, it's got to pick up speed. It has to go faster than the bottom speed, than the bottom. You notice you can tell by the curve. Remember when we talked about in chapter 2 what a derivative was? The derivative was a rate of change. The rate of change is speed, velocity, acceleration. So the faster it goes, the more distance it has to travel. What's happening here is it's pulling up on that wing. Because it's going faster, it's pulling up on it. If you don't believe me, put a piece of paper on the table and blow on it. One of two things can happen. Either it's going to suck down onto the table or it's going to lift. Why? Because the air itself, the air going over it is lifting it up. That's what we call lift. So that's what I'm saying. That's what mathematics, because remember, it's the first derivative. Of the speed, of the rate. So as the wind picks up velocity, it causes a vacuum. And that's what lifts the wing. And that's like, if you ever notice an airplane, do airplanes fly level? How do they fly? Yeah, they fly like that. Well, if the airplane, if you see the airplane like this, the wings are like that. It's called the camber. Because as the airplane's flying, you need something to push down against. The bottom part's pushing down, the top part's lifting up. So that's how we stay in the air. Now, how does it slow down when it's flying?
Level.
It won't slow down at that point. All it does, when it goes level, it starts, it tilts more up, yes. So the more steep the wing, eventually there's not enough lift for this air going over it. We call that a stall. And it gets to be so much. So there's, you don't change the, if you don't change the power of the engines and you increase the angle of attack, the camber of the angle of the wing, pretty much what you've done is you just killed the lift. The lift that used to be on top of the wing is now gone. Only thing left is gravity. And that's where you start sinking down. And that's, if you notice, when airplanes come in for a landing, what do? They come like this. Another thing happens, two more things happen on the wings. These are called flaps or ailerons. What they do is they go down. In other words, you don't have to change the speed of the plane. What's happening now is this wind here is now pushing down. It's now you have a little bit of lift, but it's also pushing down. So when there's, if you're ever on an airplane, you hear you look outside, you see the wings get longer. That's why. The flaps go down, and this part here, which is the leading edge, because now the airplane is doing this, it's got to change. So as the wing goes up, this leading edge has got to tilt down, so it's still bringing the wind over. A lot of mechanics, all this stuff is all mathematical. All this stuff happens because of necessity to stay aloft. Did the Wright brothers have this? No, but they defined a lot of the stuff. Michelangelo or Leonardo da Vinci actually thought this stuff through. They just didn't have the math to prove it all. So there's an example of math and physics. Actually, math and engineering, math and everything. Because before you build anything, it's got to work mathematically first. If it doesn't work mathematically, don't build it. It won't work. A ship. Can you build a boat out of concrete? A canoe? The answer is yes. The universities, if you go to UT Austin, the engineering departments have a competition where your team has to build a canoe out of concrete. And whoever is able to go the furthest down the river wins. So now you look at concrete's heavy. How do we dissipate the heaviness with buoyancy? Because yeah, or put some floaty things inside there and cover it with the concrete. You're still now at the floaty thing there. It's empty space, so it keeps it afloat. Don't make the concrete solid. Make it into a shell because you have air inside there. Air floats. So yeah, that's what I thought. I thought it'll never float, but yeah. And they show videos of these things, these concrete boats that weigh a couple 100 pounds. But think about it. Let's go further. What's heavier than concrete? Metal. What are ships made out of? They're made of billions, not millions, but millions of tons of steel. I mean, these things are so big. If you look at one of the rivets, just the rivets alone, it's as big as your hand, just one rivet. And think of how big the ship is, how many of them they have to have in there. A rivet is, when you're going to put two sheets of metal together. Okay, if you put two woods together, you take a nail, put it in there.
Oh.
But for metal, you have to put a rivet, which is a screw type on one end, and you put it through the hole, and you butt it up against another one, and you push it in there, and they fuse, they melt together. That's why they have to be super hot when they do it, so that when you do push them together, they become one piece of metal. The bridge in Sydney, Australia has over 3 million rivets. And each of these rivets, they should literally, it's as big as your hand. And that's just the rivets themselves. Then you have the beam. So all this stuff has to work before you go any further, and you have to plan it all out. And why does a ship stay afloat? Because of buoyancy. The wider it stays apart, the more surface area against the water, the more you can say you can have float. Don't believe me? Aircraft carrier. Aircraft carrier literally is a city on the water. They have over 4,000 people that live on board. They have over 80 airplanes, helicopters, other rescue ships, and it stays afloat like it's nothing. Oh, here's another cool thing. Before we get to the example. What do ships sail on when they're in the water? What do they sail on? Was that? Like a luxury ship, like a Disney cruise liner or a Royal Caribbean. What do they float on? The propellers pushes it. And actually, what is it's air. It used to be the bottom of the ship in the water. It used to be just the bottom of the ship in the water. But eventually, well, barnacles, things grow down on the bottom of the ship. That's why every couple, like 6 months or so, they got taken to dry dock and scrape them all off. And when you have that, it destroys the aerodynamics of it. So you have to have more gasoline to make your motor work harder to move the boat as far. So what they do now is on the bottom of the ship, they have these millions and millions of little holes. And what air is pushed out. So they're floating on air. They're not touching the water really, they're floating on air. It's a lot faster. When you ski, everybody thinks you ski on snow. No, when you ski, here's the snow. This little area here, the friction between the ski and the snow melts. And that's the only reason you move forward. That melts. And then what happens when snow melts? It becomes water. So what you're really doing is water skiing. It's not snow skiing because between you and the snow, there's a layer of water that the ski is, because of friction, is making it melt. And that's what makes you move forward. See, that's why I love mathematics and physics. It's just so amazing. And also astrophysics was my first major when I was in Germany. Because I could be able to look at any object in space, and I can tell you exactly what it's going to be in 5 minutes, 20 years, 10 decades, a century. I can tell you exactly where it's going to be by its movement. That's pretty cool. But anyway, I know you're bored. Let me go on with the example. Example 3. A rectangle is to be inscribed in a semicircle of radius 2. What is the largest area the rectangle can have? And what are its dimensions? The first thing is we have to understand what the question is saying and draw a picture of it. So what is it saying? A rectangle. What does a rectangle look like? Yeah, I was thinking Hershey bar. I love chocolate. So it's a rectangle, it's a Hershey bar. It looks like this. You're right. It's got two lengths and two widths. Are they the same size? No. If it had the same size, they'd be square. These lengths are bigger than the widths. Is to be inscribed. What does inscribed mean? Inside. Scribed means written. So this rectangle is to be drawn inside. In a semicircle of radius 2. What's a semicircle? Half a circle. So this rectangle has to be inside a circle or half a circle of radius 2. The radius is from the center to the circle. From center to the circle, it's 2 units. And there's a rectangle inside there. So the radius equals 2. Do we have any formulas that we can use so far that deal with circles and radiuses, radii? Pi r squared, but yes, but those are equations of areas of circles or circumferences of circles. Good start, but no. 2 pi, that's the circumference of the circle. That's the outside.
Then radius.
Actually, it's more basic than that. If you would have taken, what's that? No, we're looking for the formula for a circle. But as we said, semicircle, that's only half of it. But we still have to know, since the radius is 2, what formula do we have? Which means from here, we can define that length there. Because that rectangle is inscribed inside there. So what formula do we know for a circle? What is that? Pythagorean theorem. What does Pythagorean theorem define? The hypotenuse of a right triangle. So we have a right triangle. Here's A, here's B, and here's C. How are right triangles and circles related? Yep, the hypotenuse is the radius, and it's the same no matter where you go to. If you think about it, any circle is made up of an infinite number of rectangles. The only thing that's the same is the radius is the same in all of those. So in this case, the A deals with the x-axis, the B deals with the y-axis, and the C is the radius. So we know the radius squared is equal to x squared plus y squared. All right, so now let's put it in terms of our picture. The height is that number right there, is this part here. That's the height. we have to have the equation of the height. Because what are we looking for? It's asking us, what is the largest area the rectangle can have? What's the formula for area of a rectangle? Length times width. Or base times height. So how does the height relate to this? Well, do we know the radius length? That's 2. We have the x-axis, and the height is the y-axis. So to find the value for h, we have to take this equation and solve for h. 4 equals x squared plus h squared. Subtract x squared. So we have h squared equals 4 minus x squared. Square root both sides. So the height is equal to the square root of 4 minus x squared. So far, so good? So we have height. We're looking for the area. As you said, the area of a rectangle is base times height. Well, what is the base of that rectangle? Is what? 2. 2, no. Because the rectangle, it goes from here and stops there. That's 2. The radius is 2. But it is 2 something,
Oh, it's
2x.
yeah.
Because you have x here and here, so the base is 2x. You just weren't finished with your answer yet. And the height we just calculated was the square root of 4 minus x squared. So far, so good?
Both sides. I'm going back a little bit.
Right here.
Yeah, right there. If you square root both sides, would it not get rid of x squared?
Ooh, good question. If I square, let's look at this, ladies and gentlemen. So if I had h squared equals 4 minus x squared, and if I square root both sides, we know that cancels. If that's the case, then why wouldn't it not be 2 minus x?
Is it because they're together?
Yes, because they're one equation. So it's going to be, but I thought the question you're going to ask is, whenever you take a x squared equals 4, and I square root both sides, that means x can be plus or minus 2. True?
Yeah.
Why don't we have a plus or minus over here? This is more of a structural thing. The height. Can you have a negative height? No, so it's an absolute value. It's only positive. That's what I thought you were going with your question. So what do we have so far? We have the area, which is a function of x, is equal to 2x square root of 4 minus x squared. And this is perfect because we have to have a function of x. There's no other variable inside there. We took x and y and made them into functions of x, or base and height. So now what do we do? What's my domain? Because the radius is 2, remember? But you're gonna ask, if that's -2 and that's 2 and that's 2, but the rectangle inside there, that's not 2 inches across. But from here to here is 2 inches. So the domain is from 0 to 2. And also because it says it's within a radius of 2. The semicircle has a radius of 2. So it's from 0 to 2. That's my domain. I have to have everything contained in there. What am I looking for here? What is the largest area the rectangle can have and what are its dimensions? Okay. The largest area. This is an extrema problem. What's an extrema? Maximum or minimum. The highest, lowest, biggest, smallest. So how do we find extrema? In other words, if we had a function like this, how would we find each of these extrema? Go ahead, go ahead. Yeah, very good. And then do what with it? Yeah, right. Because at each of these places, the slope is equal to 0. It's a horizontal line. Slope is the first derivative. So we take the derivative, set it equal to 0. And then we find the x values, and then we plug those back in there. So we got to take a derivative of this. So how do we take a derivative of that? What method are we going to use? This times this. This times this. What is another word for times in mathematics? You're taking the what? What is it called? It starts with a P. Ends with product, right? It's a product. So we got to use the product rule. Here's f of x, g of x, f prime, g prime. So the first one is f of x, which is 2x. And then the other one is square root of 4 minus x squared. 4 minus x squared can be rewritten as 4 minus x squared to the power 1/2. Well, the derivative of 2x is 2. The derivative of this one, take the derivative of the outside, which is, and subtract 1, which makes it negative 1/2, times the derivative of the inside, which is what?
What? 1 over 4 minus x squared.
The derivative of the inside. The derivative of 4 minus x squared.
4 minus, oh, no, 8.
Minus 2x. Because the derivative of 4 is 0. The derivative of x squared is bring on, so it's minus 2x. You were getting there. So we cancel the 2's. So this one becomes negative x over 4 minus x squared to the power of 1/2. Now we do the fishy thingy. Since it's a product, we add. So the derivative is 2 times 4 minus x squared to the power 1/2 plus 2x times negative x over 4 minus x squared. Two, 4 minus x squared to the power 1/2. Oop. Negative times positive is negative. 2x times x is 2x squared. Four minus x squared. Which becomes 4 minus x squared, square root of it, minus 2x squared over square root of 4 minus x squared. So far, so good? Now what do we do? What are we looking for? The maximum minimum. Okay, we just took the derivative. Now what do we do with it? Set it equal to 0. Because we have to find the x values and where it is an extrema. So we set it 0 equals 2 square root of 4 minus x squared minus 2x squared over square root 4 minus x squared. What do you got to do first? Here's the rule of thumb. Whenever you have fractions and an equal sign, get rid of the fractions first. How? To remove fractions, first, find the LCD. What's the LCD? What is the LCD? We all know the definition of the word of it, but what is it in this example? What's the only D we have? Square root of 4 minus x squared. The only denominator we have is that one. So we found the LCD. Multiply each term by the LCD. So it's 0 times the square root of 4 minus x squared equals square root of 4 minus x squared times 2 square root of 4 minus x squared minus 2x squared over square root of 4 minus x squared times square root of 4 minus x squared. So we found the LCD, multiply each term. How many terms do we have in our original equation? 1, 2, 3. A term is anything separated by plus, minus, or equals. So we have 3 terms. So we have to multiply it to each of those 3 terms. Third step. Reduce. Cancel what you can. In other words, the reason we do this is there should be no more denominators after this step. So the square root of 4 minus x squared, those cancel. Notice we have no more fractions. Multiply to remove the parentheses. So 0 times anything is 0. Square root times square root is the square root of 4 minus x squared squared. And get this through. Looking at these two equations, which one looks easier to deal with? The bottom one, because it's less work. So now we got to solve for x. So the square root and the square cancel. So we have 0 equals 2 times 4 minus x squared minus 2x squared. Distribute. 2 times 4 is 8 minus 2x squared minus 2x squared. 8 negative 2x squared negative 2 is negative 4x squared. Add 4x squared to both sides. So we have 4x squared equals 8. Divide by 4. X squared equals 2. Now what? So what's the answer? The x squared, the square and the square root cancel equals what? Plus or minus. Well, think about it. Can it be negative? Because remember, our semicircle is from -2 to 2. Is that the area, or is that simply an x value?
Oh,
So it's going to give us the same answer. It's the negative side. So right, because they're going to give us the same answer, all we have to look at is the positive side. Makes it easier for us. So that's going to be one of our values we have to check. Remember, we always have to check at least 3 values. This one. What are the other 2 we have to check for sure? The endpoints of my domain. But you're right. I see what you're saying. It was negative positive. If we did that, we'd get the same answer in the equation, because it's just going to be on the left side or the right-hand side. So, but we have to look at the extreme, at the endpoints. What happens? Because remember, my domain was from 0 to 2. I have to check A and B. Why do I have to do that? Ooh, here's another way to look at it. Why can I not use negative square root of 2? Is it in the domain? No. So I could only use the positive side. So what we're looking at here is since the function is continuous, we have to look at all possibilities. The A, the B, and any C value we look at. So what do we do with three values? Where do we put them? Which equation? Yeah, so here we're saying the area with square root of 2, the area with 0, and the area with 2. So where's our formula that we dealt with earlier? Right. That's the formula we'll be using. AX is equal to 2x square root of 4 minus x squared. So we got to do 2 times square root of 2. Four minus square root of 2 squared. What is the square root of 2 squared? Just 2. So 4 minus 2 is, so this is equal to just the square root of 2. But it's inside the square root. So the square root of 2 times square root of 2 is 2. 2 times 2 is 4. So that's that one. Because we had this square root of 2 here. Inside here, we had 4 minus square root of 2 squared. Square root of 2 squared was 2. 4 minus 2 is 2. It's still inside the square root. So we have 2 square root of 2 times square root of 2 is 2 times 2 is 4. So this is the first area. When it's 0, four minus 0 squared, it doesn't matter because 2 times 0 is 0, and so that answer is 0. Bless you. 2 times square root of 2 times 4 minus 2 squared. 2 squared is what? 4 minus 4? Square root of 0? 0 times anything? 0. So our area is what are my dimensions? Remember, area is base times height. So since the area occurred at 4 at square root of 2, so when x equals square root of 2, we get the base equals 2x, which is 2 times square root of 2. And the height is square root of 4 minus x squared. Four minus square root of 2 squared. Four minus 2, which is square root of 2. So these are the dimensions. That one was mostly algebraic. Any questions? All right, let's look at example 4. The speed of light depends on the medium through which it travels. And is generally slower in denser media. What does that mean? What does density, what does denser mean?
Like
Thicker. Like
air.
water or molasses. Honey versus milk. It's the thicker the material, the slower it goes. Yes, this is going to, we can go to a whole discussion because this is, remember, this is light. Speed of light. That means the only way that could be affected by it is if what? No, if light has mass. The only reason it slows down is because, well, can you run as fast in water as you can through honey? No, because you have mass, you have resistance to it. There has to be something that makes you slower. So that's where Einstein was saying that is light has mass because it bends, it moves. Which is why if you like the eclipse we had, if the moon, here's a cool thing there. Here's the Earth. Here's the moon. There's the sun. Remember when they had that eclipse last year? Why did it occur that way? Why was it a perfect lunar eclipse? Because the proportion, the distance from the Earth to the moon, as opposed to the moon to the sun, is the same proportion as the density, as the size of the moon to the size of the sun. They're each 400 times. So the distance from Earth to the moon, as opposed to the moon to the sun, this is 400 miles. This is 1 mile. This is 1 inch. This is 400 inches. Because of that perfect proportional ratio, the moon covered the sun perfectly. Here's the problem. If it covered the sun perfectly, how can we see the corona? The corona is the crown, is the outside the chart. The only way that could be true is the sun sends out light. Because of the gravity, it has mass. Because of the gravity, it bends back. That's the reason we saw it. In other words, here's the sun. It shot out, and the sun and the light rays did this because of gravity. Because light has mass. That has to do with, yes. Yes. So very good. A lot of people don't know what plasma is. So here we have Fermat's principle in optics states that light travels from one point, let's call that A, to another point, B, along a path for which the time of travel is a minimum. Before we go any further, why? Why is that such a remarkable statement? It's obvious, but why is it a remarkable statement? This states, the light travels from one point A to point B along a path whose time of travel is a minimum. Think of everything in nature. Path of least resistance. You ever hear that phrase? If you were to go someplace, for example, let's say you're at rush hour, are you going to go right through the middle of traffic, or are you going to go through around the traffic? Around the traffic, because it's faster, it's least resistant. Same thing with light. It moves from point A to point B along a path in which the time is minimum, meaning the fastest time. Duh, because if we see light, we see the fastest light that gets to us. Once we see the light, it doesn't matter what light comes after it, because we already saw that first light. And that's what he's saying. All right. Now he says, this is the question. Describe the path a ray of light will follow in going from point A in a medium where the speed of light is C1 to a point B in a medium where its speed is C2. Draw a picture that describes that. What it's trying to tell you. And let's go and put together some formulas. So this is Fermat's principle of optics. A light goes through where it's fastest. Describe the path. Okay, we have median A. So here's path A. It starts in this one. It goes somewhere. This is from A. Its speed is C1. Here, this is one median. Here's a second median. Its speed is C2. I did it this way because I ran out of space in the bottom. Typically, what happens here is this. Have you ever looked at a pond and saw fish? So if you're standing here and you're looking down, and here's the pond, and here's the fish. This is point A. This is where you're starting from. And here's B. Is the path that you're seeing from you to the fish, is that a straight line? No. What happens to that? It bends. Yeah, it bends. Depending on the median. The thicker the median, the more it bends. So it diffracts the light further down. So we have one angle here, and we have another angle of diffraction there. So what are we looking here? Describe the path of light as it goes from A to B. How do we define this? What do we know so far? What are we looking for? Because we're talking about speed, the speed of light, and the time is at a minimum. So what we're looking for here is time. What's the formula for time? Well, we have a motion problem, don't we? Distance equals rate times time. Anytime we deal with motion problems, anytime anything moves from point A to point B, that's a motion problem. In this case, it's light. Distance equals rate times time. So time, if I divide both sides by r, is distance divided by the rate. Let's look at this first part. This is point A. So the point, we'll call that B. That's the point P. That's the beginning, that's the top of the water. Because here he's on land, or you're on land, and here you're in water. So we have time equals distance times rate here, and we'll call that 1. Time 2 equals distance over rate. What's our rate for this first part, or this part here? Remember, it said C1. In the question, it said C1. So what's the distance? The distance is from here to here. How do we find the distance? We can't use the same formula, because if we use that same formula, because now we're looking for the distance, physical distance. Physical distance from this where we're observing to where it hits the water. That's distance. So it's X and Y. Pythagorean theorem is the distance is equal to x squared plus y squared, or the distance equals the square root of x squared plus y squared. But we're starting from A. So this value here, the height of this is A. So it's the square root of A squared plus x squared. How about the same thing for over here? How do we do that? We're going to point B. So here's that distance. The speed of 2, the rate of 2 was C2. Can't be, because this and this are two different angles. So how far is this? And how far is this distance is B. It's going to be. What is this horizontal distance? Well, here we had this, which is the x value here, but now how do we figure out this one? They can't be the same. How do we find the two distances? Because of the refraction, how far? It can be the same, but it doesn't. But we have to come up with a formula where it can be, but it doesn't have to be the same. So we're saying this value, this distance is A. There's A, B, C. This is D. So how far is this? This distance here is D minus X. Because on the horizontal axis, we don't know how far it goes, but we know that subtract it and we get this distance here. So we have our Pythagorean theorem now. This distance, so D2 is equal to B squared plus D minus X squared, which is the distance squared is the square root of B squared minus D minus X squared. Plus. That's nice. So that's D minus X squared, D plus. So it's a square root of B squared plus D minus X squared all over C2. Remember, what does this formula define?
How far is it? Oh,
The time it takes. Yeah, because remember, this is a T D over R. This is the formula for T. This formula is how long it takes the time from here, and this one takes the time from here to here. So how do we find the time?
the total.
Total time.
You just have it.
Yeah, so it'd be this first one, which is square root of A squared plus X squared over C1. square root of b squared plus d minus x squared. So that's the time. What were we looking for? We're looking for the time, the minimum amount of time it takes to go from one medium to the other medium. That's Fermat's principle of optics. How do we find the minimum time? Yep, we have to take the derivative. Since time is a function of x, we have to take the derivative of that function. So let's look at both of these separately. One. Let's take the derivative of this function. So to take a derivative of this one, we have to first rewrite it that way. So what's the derivative? C1's a constant. We can move it out in front. So take the derivative of this. How do we take the derivative of that? Take the exponent. What's that rule called? The power rule, whenever you have an exponent, bring it down in front, subtract by 1. But since we have an inside function, that's called the chain rule. Remember the chain rule? So we take first derivative of the outside, which is 1/2, and subtract 1, which is negative 1/2. Then we multiply by the derivative of the inside. The derivative of a squared is 0, because it's a constant. Derivative of x squared is 2x. So the 2's cancel. We have x over c1 square root of a squared plus x squared. So that's the derivative of this first part. Now we have to take the derivative of the second part. Which will be bigger because it's got more moving parts in there. The derivative of b squared plus d minus x squared to the power of 1/2 over c2. Since c2 is a constant, it's going to stay on the bottom. We just have to get derivative of the top. So the derivative of the numerator. The 1/2 goes out in front. Subtract 1, which makes it negative 1/2, times the derivative of the inside. The derivative of the inside, the derivative of b squared is 0, it's a constant. So we have this one, the derivative of d minus x squared. It's a chain rule also, so bring the two down. And take the derivative of the inside. Is -1. The derivative of d minus x is -1. So the twos cancel. We have on top d minus x minus 1 over square root of b squared plus d minus x squared. No, it's not. This is times 1. Times -1. We have so that is our second part. We have C2 square root of b squared plus d minus x squared and d minus x on top. Oh, that -1 makes this a negative. Because remember, we take the derivative of the inside, it should be -1. And that -1 changes that. Now what do we do? Set it equal to 0. What we have? Oh, we have 1 over C1 x over square root of a squared plus x squared minus 1 over C2 d minus x. The sign deals with which axis? Think of the unit circle. At 0 degrees, what is that location there? That's 1, 0, isn't it? So it's cosine of 0, sine of 0. Cosine deals with the x-axis, sine deals with the y-axis. Since this distance formula is defined by that, we're dealing with a vertical, so that's a sine of this angle. And likewise, our depression is angle 2. So we could just use this formula. It's in your charts also in your formula sheets. It's not necessarily that well understood or not understood. It is understood because we can convert from any graph to sine and cosine. What we're looking for, because if we set this equal to 0, we would be hurting. Why? Because we'd have to take both of these radicals and multiply it by the entire function by that LCD and then simplify those radicals. It would give us more headache than anything. It wouldn't be easily solvable. But this side, it is easy. Because if you look at this, if it's equal to 0, so we have this minus that, we could move this entire equation to the other side, which gives us 1 over C2 sine theta 2 equals 1 over C1 sine of theta 1. What are theta 1 and theta 2? These angles, what do they represent? The angle, when you're whatever you're looking at, is angled down, you're looking at it. And this is the angle of declension, how far it's going from the water down. So what do we do here?
How to find.
There's, determine the path the right takes. Well, that's the path it's going to take. Depending on, because the speed of light is speed of light 1 equal to speed of light 2? No. Why? Because what makes it different? Because the density makes the light bend more. So your angles are different. Since the angles are different, you have more time to travel. Think about this. So if you have to go further, the time's going to take longer, which is what we, as a result of the density, because it's bending the light and making it travel further. So now what we have to look at here is depending on what the speeds of light. So this is as far as we can get. Whereas all we can get is that ratio. Because we don't know what angle we're dealing with. We don't know what actual comparison of the speed of lights are. If I give you any one of the informations, if I give you the angles, or if I give you the different speeds of lights, then you can find everything else. This is called the law of refraction. What is refraction? The bending of light. It was invented by a physicist named Snell. That he said he was looking at fish in the pond and he noticed that what I'm looking at, if I try to grab something right there, I'm going to miss it by a mile because they're further below what I'm trying to reach. And that's what he said. If you ever went spear hunting for a fish, if you're walking along, you see a fish, you try to throw a spear at it. If you shoot it where you're looking at it, you'll never hit it. You got to aim it further down because that's the refraction. Okay. I wish that the example, I'll give a better example next time of another thing in physics that because optics themselves are very difficult because again, you have to deal with many factors. The clarity of the instrument you're looking at, how far are you, the density of the object. Economics. Profit. Profit is equal to what?
Cost minus
Revenue, what it costs to make, or what you sold it for, how much money you made, minus the cost. So the profit, these are all functions of the number of items that you produced and sold. So profit equals revenue, how much money you made, minus how much you spent to make it, that's profit. Now, the change in any of these are found by finding the marginal change. So marginal profit is equal to the derivative of the profit. It's the change, rate of change. Marginal revenue equals to the change of the revenue. And marginal cost is equal to the derivative of the cost. Let's look for an example. So the marginal profit is the marginal revenue minus the marginal cost. So here's our example. Example 5. Suppose that the revenue function was 9x and the cost function was x cubed minus 6x squared plus 15x. Where x equals millions of MP3 players produced. The question, is there a production level that maximizes profit? If so, what is it? So how we go out finding this? What do we have to do? Yeah, because why do we know we have to take a derivative? It's asking for the maximum, the maximize. So what we have to do is, well, go to the next page. So we have the revenue equals 9x and the cost equals x cubed minus 6x squared plus 15x. First. So we have to find the derivatives. R prime is equal to 9. The marginal cost is equal to what? So squared. Very good. And what do we do with those two? Because we want to see at what point do we start making more money, maximizing it. If we set them equal to each other, what happened? What are we looking at? That's the breaking even point. Because at that point, we know at what point do we break even? Because anything after this amount, I'm making money. So go ahead and solve for it. We have R prime is 9 equals 3x squared minus 12x plus 15. Any more? So what do you do first? Oh, we have to make it equal 0 first. So 0 equals 3x squared minus 12x plus 6. Factor out of 3, we have x squared minus 4x plus 2. Can we factor it? No, because what times what is 2 when you add them, you get 4. No. So it's gonna be a fraction, it's gonna be, or a radical or imaginary even. So we have to use what method? I'll give you the clue. The quadratic function. Remember the quadratic function? That's negative b plus or minus, our gradual formula, b squared minus 4ac over 2a. The quadratic formula. So what is, we have to label A, B, and C first. What is A?
3.
1. What is B and C? Very good. Because remember, in this, the only variable we have is what we're solving for. So only thing we put inside there are numbers. So x is equal to negative b. So it's negative of negative 4 plus or minus square root negative 4 squared minus 4 times a times c over 2 times 1. Negative, negative makes it a positive. Negative 4 squared is 16. Minus 4 times 1 times 2 is 8 over 2. 16 minus 8 is 8. What do we do now? Can we simplify inside the radical? Let's see. What is 8 made up of? 2 times 4, 2 times 2. So this is 2 times 2 times 2. Since it's a square root, there's a 2 there. Once we have 2 of a kind, that can come out of the radical. So we have 4 plus or minus 2 radical 2. On top, 4 and 2, we can factor out a 2. Use cancel. So x can equal to, those are my two answers. X is equal to 2 plus radical 2, and x is equal to 2 minus radical 2. So the question was asking, is there a production level that maximizes profit? So those are our vertices or critical values. Which one maximizes profit? How do we find it? We're looking for profit, aren't we? Well, yes, but we have to know what the value is. Because we have two values, x. Which one is going to get? It's a cubic function. What does a cubic function look like? So we're going to have one maximum and one minimum. Which one's which? We don't know. There are two ways we can figure it out. One, we can go ahead and plug them both in the profit formula. Or we have another method we use in calculus. If you can determine if this is a maximum or a minimum. How? Second derivative. Remember, what does second derivative find? Concavity. If it's a maximum, it's concave down. It's a maximum. It's a minimum if it's concave up. So what do we take a derivative of? Or how do we find the second derivative? Second derivative of what? Remember, we're trying to find the profit function. This has to be a profit function. What's the formula for profit? Profit is revenue minus cost. You could go ahead and plug in the values for x in those two and see which gives you a bigger one. Then you know that's the maximum. Or we can figure out automatically right now which one's going to give us in here. How do we do that? We first plug all that stuff in there. So we have P of x is equal to 9x minus 3, oh no, it's x cubed x cubed minus 6x squared plus 15x. The first derivative will give us 9 minus 3x squared minus 12x plus 15. Distribute that negative sign. We have negative 3x squared plus 12x minus 6. And how do we find the second derivative? So it's negative 6x plus 12. If we take out a negative 6, we're left with x minus 2. What does, if we set the second derivative equal to 0, what do we get? What is that called? So it equals 0 when x equals 2. This is called the point of inflection. What is the point of inflection? If our graph has a maximum minimum in it, the point of inflection is where it stops being concave up and starts being concave down, the second derivative. Why is that important? Now we know where the point of inflection is.
Is that when you, cost?
That's when everything's equal. Because, yeah, because here on the left side, in this case, if there was this picture, we would have a maximum. So to the left of it, our values would give us a maximum. To the right of it, it's going to give us a minimum. Because at this side, so if the second derivative is negative, that means it's concave down. If the second derivative is positive, that means it's concave up. If it's concave down, we have a maximum. So what values do we plug in there? Yeah, the values that we're looking at here are our x plus or minus 2 plus or minus square root of 2. So at the second derivative, 2 plus square root of 2, plug that in there, see what happens. So it's negative 6, 2 plus square root of 2 minus 2. The 2's cancel. So we have negative 6 and then if we have the 2 minus radical 2, negative 6, 2 minus radical 2 minus 2, the 2's cancel. So we have negative 6 times negative radical 2 makes it positive 6 radical 2. So what does this tell us?
That. Plus
2 plus radical 2, since it's negative,
It's, maximum.
it's the maximum. Because it's concave down. And the other one is concave up, so this is a minimum. So far, so good. It asked us, if it occurs, does it occur? Yes. Where? At what X value? Which is 2 plus approximately 1.2, approximately 3.2, at that X value. All right. That does it for that section. Unfortunately, I have to get my tire has a puncture in it. I have to get it fixed. And we'll finish